So this is a short proof why the number of orbitals present in a shell is n square. Short proof. So we'll start with assuming there is an nth shell we're talking about of an atom. The number of subshells are also equal to n, right? Yeah, though they are named a bit differently. You talk about SPD, or you talk about the azimuthal quantum number. No, going with the azimuthal quantum number, for example, if you have the subshells SPD, then they are named as 0, 1, 2. Though these are subshells. These are three subshells, but they're named as 0, 1, 2, not 1, 2, 3. So you can see if, for example, we are on the third shell. We're on the third shell. Third shell. There are three subshells, but the last shell, what the last shell, how much it is? It is equal to 3 minus 1. This third shell or three subshells subtracted 1, because we are starting with 0. Similarly, we can say that for nth shell, there are the number of subshells are also n. So nth shell, number of subshells are also n. Subshells number. This is the nth shell. This is not the nth subshell. N is the number of subshells. For an nth shell, n is the number of subshells. And the last subshell, the azimuthal quantum number, that is the L. The last subshell has an azimuthal quantum number of n minus 1, which is the azimuthal or L of last subshell. Last subshell ka azimuthal quantum number is n minus 1. Oh, sorry, n minus 1, right? So let's begin. We're talking about an nth shell, right? So there are n subshells, and n minus 1 are the L of last shell. Okay, let's not derive just n square. Let's derive 2n square. The number of electrons also. See, right? It's just multiply by 2. Okay. So, anyways, so let's say for this n shell, there are n subshells. Now, for the first subshell, we know the formula for orbitals. What is the formula for orbitals? The formula for orbitals, I'm sorry, it's 2l plus 1. Why is it? It's because the L, not the L, which is, I'm talking about the magnetic quantum number, it varies from minus L to plus L, right? Including a 0. So if you talk about the range, the number of shells, let's say for this, the number of orbitals, sorry, the number of orbitals for, let's say, L is equal to 2. L is equal to 2 means we are on SPD, right? We're on D. So it's range from minus 2 to 0 to 2. These are all the axes and all the orientations. So minus 2, minus 1, 0, plus 1, plus 2. So you can see clearly uh, these are two options or two orientations. These are two orientations. These are orbitals, or you can say the orientations for the orbitals. The orbitals vary as their orientations, right? Different orbitals have different orientations. So you can say these are just like the number of orbitals. So these are two orbitals, or the orientations. These are also two orbitals, and the number is of course same because it's minus L to L. So L minus minus L is 2L. Okay, but if we are also including, of course, when we're doing the minus, we should also include this minus L. But In general terms, when you are including the 0 or when we are talking here in subtraction, we show either you should include this minus L or include the 0. So anyways, so the formula for the number of orbitals becomes 2L plus 1, and this these are the magnetic quantum numbers, we'll not talk about them. Okay, so 2L plus 1 is the formula, is a general formula. यहाँ पर तो L तो मैंने last लिया है. 2L plus 1 is the general formula for finding the number of orbitals. Right. Now let's say for this nth shell, of course these azimuthal quantum number starts from 0. So for the first orbital, sorry, for the first shell, for the nth shell, the first subshell has orbitals 2 0 plus 1, right? 2 0 plus 1. The first subshell has an L of 0, so 2 0 plus 1 is the number of orbitals. And similar, this second subshell has the number of orbitals as 2 1 plus 1, and the third has 2 3 plus 1 number of orbitals. I'm talking about the subshells, and so on till you reach the last azimuthal quantum number. Here we're erasing the azimuthal quantum numbers by 0 1, sorry, 2, it should be 2. So we are increasing them by 1 and we are starting from 0. The last azimuthal quantum number for this whole series will be what? N minus 1 plus 1. Now we just have to simplify. Now how many times it is written, this formula 2L plus 1? How many? 1 2 3. How much times is it written? Is it written n minus 1 times or is it written 1 times? It's written n times. Not 1 times. It's written n times, not n minus 1 times, because we are also including the 0. Let me tell you why. For example, let's say we are on pth not pth subshell. We are on the second shell. So the subshells are S and P. The number of orbitals in S is 2 0 plus 1. Number of orbitals in this P subshell is 2 1 plus 1. Right. Now if you see how many terms are there of 2n plus 1 form, there are 2 terms. And what's the last azimuthal quantum number of the last term? It's 1. But we have 2 terms and it's 1. Why? Because we have included a 0. If there was 1 instead here and there was 2 instead here, the number of terms in the last azimuthal quantum number would have been equal, but they're not. So the number of terms is this plus 1, or n minus 1 plus 1, that's n. So there are n number of terms. There are how many? N terms. N terms we have. So let's simplify. Let's take 2 common. We have 0 plus 1 plus 2 plus dash 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 plus n minus 1. This is not the number of terms but the last term. N minus 1 is the last term. Plus 1. How many times is 1 repeating? It's repeating n times, because there are n terms, or n minus 1 plus 1. There are 1n. Now what's the formula for this series? It's AP, but it's starting from 0, not 1. The first term, see how many number of terms are there? We know there are n number of terms, so n by 2. The first term plus the last term plus 1n. 2 cut gaya. It becomes n square minus 1n and just plus 1n. So n square is the number of orbitals present in nth shell, and because each orbital can carry 2 electrons, 2n square is the number of electrons that can be, keyword can be, present in an nth shell. 2n square, the maximum number of electrons. That's it.